So here's our next topic on solubility. What we're going to look at today is how well certain substances can dissolve in water, and how do we measure that or quantify it and actually give it a number. So first definition for you to fill in is your definition of solubility. So solubility is sort of the limit or the maximum amount of solute that will dissolve in a specified amount of solvent. So it's typically expressed in grams of solute per 100 mils of solvent. So it's usually, say, grams of some sort of ionic compound for every 100 mils of water. So these are our units, grams per 100 mils. The values are temperature dependent, okay? So that means that the solubility of, say, sodium sulfate at 0 degrees is 4.76 grams per 100 mils of water. And if we change the temperature here at 0 degrees, if we say increase that temperature, we're going to change how much can dissolve in water. So our rule of thumb is for solids, and we're going to look at this a little bit later, but for solids, hopefully you know from just your past experiences that if we heat up our solvent or our water, we can actually dissolve more solvent in there. For gases, it's the opposite. Gases don't dissolve as well in a warm solvent, or yes, sorry, in a warm solvent. So they would want a cooler or less temperature to dissolve more grams of gas. All right, so let's look at a couple more definitions for you. A saturated and an unsaturated solution. So an unsaturated solution is a solution that's below the solubility limit, okay? So if we go back to my example of sodium sulfate, let's say I have a solution, I have water, and it's at 0 degrees Celsius, just to keep things simple. If I only, say, put 4.2 grams in 100 mils of water, sorry, that should be a 1. So in 100 mils of water, I know from here that I could still add more to that because I can add up to 4.76 grams in 100 mils of water. So this would be a solution if I only put 4.2 grams in 100 mils of water. If I only had this, that would mean that the solution is unsaturated because I can still add more. So I'll add more solute. All right. A saturated solution, on the other hand, is a solution that is exactly at the solubility limit, okay? So the example that I could give you for that is, again, if I have my sodium sulfate, again, if I had exactly 4.76 grams in 100 mils of water, that would be a saturated solution. If I add any more, it won't dissolve. So that's what saturated means. And then the next two definitions are probably very new for you. So supersaturated solution. A supersaturated solution is a solution that is above the solubility limit, which is called sort of a metastable state. These solutions will quickly crystallize out if seeded, which is either accomplished by adding a small seed crystal or by scratching the side of the glass container. So an example of this, if we again use my sodium sulfate example, would be if I, say, had 5 grams dissolved in 100 milliliters of water. Okay, because so I basically have more than I should dissolved in that solution. So the question now usually comes up is, okay, well, how do you make a supersaturated solution? Because I know, like, if I'm adding something to water, I can add a certain amount, I can get my saturated solution. Then if I add any more, it's not going to dissolve. So here is how you're going to make I think I have it on the next slide, actually. So a saturated solution, what you basically do is you heat up your solution so that it can dissolve more solute, and then you really, really slowly cool it down. And we're actually going to do a lab on that and try to actually make some of these crystals. So you can see my picture that I've got here. This is a supersaturated solution, and it looks like a regular solution, but if you seed it, so if I drop one more little crystal in, you can see all these crystals in here start to form, and the whole thing will eventually become like one sort of solid mass. So that's what a supersaturated solution is. Last one is oversaturated. And again, it's also past the solubility limit, but this is where you see undissolved solute at the bottom of the beaker. Okay, so it basically consists of a saturated solution with extra solute. So if I go back to my sodium sulfate example, let's say I had 4.8 grams that I put into 100 mils of water. An oversaturated solution would be if my 4.76 grams dissolves in water and I have, say, 0.04 grams left over sitting in the bottom of my beaker. That would be an oversaturated solution. So there's a difference between supersaturated and oversaturated. Supersaturated is everything's dissolved, but it's really, really unstable because it shouldn't all be dissolved. And oversaturated is when you have extra solid at the bottom of your beaker. All right. So your solubility curve worksheet, you guys are actually going to have a worksheet, or I guess an assignment on this to do in class. And so I'm going to teach you a little bit about solubility curves before I give you the assignment. So a solubility curve basically shows you the amount of solute that can be dissolved in a certain volume of solvent at a particular temperature. So we've got this really cool graph here, which shows a bunch of solubility curves of different salts. So the lines on the graph represent the saturated solutions. If you end up with your point below the line, you're unsaturated. If you're above the line, you either have an oversaturated solution where some remains undissolved, or you have a supersaturated solution. If you have your textbook, there's another picture of this graph on page 394, but I'm going to use this picture here to go through a couple of questions with you. So here's my same picture, okay? And what we're going to do is sort of answer these questions. So it says, at 70 degrees, how much KCl, or potassium chloride, would dissolve in 100 mils of H2O to have a saturated solution? So my first step is to find the line that has KCl. So it's this line right here. Okay, so there's my KCl. So I can sort of ignore all the other lines. I know it's messy and it's a little bit busy, but just ignore all the other lines. That green line is basically what we're going to focus on. So now we have two things to look at. We've got our units here, which is a grams per of solute in every 100 grams or 100 milliliters of water. Remember that 1 gram of water equals 1 milliliter of water, okay? So if I say 100 grams or 100 milliliters, it's the same thing. And then down here, I've got my temperature. So for this question, I have to look at 70 degrees. So that's here. So I'm actually going to go up, 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 up to about there. Okay. And I see where I hit the green line. So wherever I hit the green line, that's where my potassium chloride would be saturated. So I've hit the green line there. So if I go over, my smartboard's a little bit off, but if I go over, it basically looks like I could dissolve about 48 grams in 100 milliliters or 100 grams of water. Okay, so how much KCl could dissolve to have a saturated solution? In this case, it's about 48. If you ended up with 47 or 49, depending on the picture, that's fine. But you should be able to see from your notes that it's definitely less than 50. All right. Let's check out number 2. So I'm going to erase all my lines on here because we're going to focus on NaCl. So for number 2, it says, what type of solution would you have if you dissolved 25 grams of NaCl in 100 grams of water at 30 degrees? So my first thing I do is I highlight my NaCl line, which is this line here. Okay. And it says, what type of solution would you have if you dissolved 25 grams in 100 grams of water at 30 degrees? So I start at the 30 degree mark and I go up to 25. Oh, so that's right here. Okay. So because my point is below the line, that is an unsaturated solution. I could still add another few grams. So this amount here in red, that's how much more I could still add before I hit the saturated mark. So I could add, it doesn't ask in this question, but if I'm starting at 25 and say going up to 36, I could add about 11 more grams before it became saturated. All right. Oh, look at that. We're going back to KCl. All right, so I'm going to erase this again. I'm going to highlight my KCl for number 3. So here's KCl, do it in red. There we go. So what mass of KCl can be dissolved in 23 grams of water at 90 degrees? Yikes, okay, this one gets a little bit tricky, and this is where your assignment's going to come in. So we're looking at 90 degrees. Okay, so if I go up at 90 degrees, okay, I hit this point here. Okay, and if I go across, it looks like I can dissolve about 55 grams of KCl in 100 mils or 100 grams of water. Okay, that's what I read off the graph, but that's not the answer to my question. So my question in this case is, what mass of KCl can be dissolved in 23 grams of H2O? So here's where you would set up a ratio and maybe do some cross multiplication. So I know that, I'm just going to erase this. I know from my graph that I can dissolve 55 grams of KCl into 100 grams of water, okay? So I read that right off my graph at 90 degrees. So the question is, how much KCl can I dissolve if I only have 23 grams of water? So it should be about a quarter. So this is where I would cross multiply and solve for my grams of KCl. So if you wanted to, you could call that x if that helps. So x will end up equaling 55 times 23 divided by 100, and I get x equals 12.65 grams. Okay, so because, again, I don't have exactly 100 grams of water, I've only got 23 grams of water, I've got to convert all of my units. So that's pretty much as tricky as it's going to get for a good chunk of that worksheet. There are some other tricky questions on there. Let's look at number 4. What temperature is required to dissolve 76 grams of potassium nitrate in 100 grams of water? So let's say I had 76 grams sitting in my beaker and I needed to dissolve all of it. What temperature would my water have to be? So for this case, I have to find my potassium nitrate curve. So it's a pretty steep curve coming up to there. So I'm just going to highlight that so you can see which curve I'm looking at. So I want to, in this case, find the temperature. So I can't start at the bottom and work my way up. I'm going to have to start over here where my units are there, grams of solute, and then find the temperature from there. So if I have 76 grams, that's about here. Okay, and that's where it hits my line right there. So then what I do is I bring my line down. I did bring it down, there we go. Okay, and it ends up being in and around 45 degrees Celsius according to my chart on here. Okay, so at 45 degrees Celsius, I could dissolve 76 grams of potassium nitrate in 100 grams of water. So that's how you read a solubility graph. Hopefully that's pretty clear for you. And that's it for this video. We're going to do more examples in class, and you guys are going to complete an assignment on this as well.